Dear students, today we are going to discuss about the experiment number 6, that is simulation of wind energy generator using MATLAB simulating. So if you take the block diagram, so this will the blocks which will be given, and we'll be discussing all the connections and how to calculate the input power and how we are going to design a closed loop control. Okay, so before that, here we have used a buck boost converter. Okay, we have used a buck boost converter. So we'll try to first discuss about this buck boost converter. Okay, so this is a buck boost converter. Okay, here you can see a diode is placed. When the diode will be forward bias, when the VA, that is voltage here, VA is greater than VK, and then diode will conduct, right? Means VA should be positive and this should be negative. Then only this will conduct. Or else, uh, you can see if voltage is applied here, positive voltage is here, and negative voltage is here, then it will not conduct, right? So diode turn on and turn off is not uh, controlled one. It will be depending upon the circuit, right? So now let us discuss the two modes, that is when switch S is turned on and switch S is turned off. Okay, move to mode 1. Mode 1, switch S is equal to on, that is S on. Okay, when switch is on, then what will happen? Okay, remember here we are discussing about the steady state analysis. Okay, steady state period. Okay, so because at initial case it is not charged one. Okay, but in steady state condition we are considering this as charged one. Okay, the only difference is here we are considering the capacitor as charged one. Okay, but here switch is on, that is supply V in. Okay, the current Is will flow through the switch and the inductor. So inductor will be charged. As you know, inductor will not allow sudden change in current. Okay, slowly it will increase the current. Okay, slowly current in inductor will rise actually. Okay, so at the same condition, whatever may be the charge in the capacitor is there, that will discharge through this resistor. Okay, please note here the polarity. Okay, the flow of current. Okay, the flow of current, that is flow of current is from here, that is positive. Okay, fine. So that is here positive and here it will be negative. So in buck boost converter, this is one of the key key feature which we have to observe, that the output terminal voltage will be actually in reverse. Okay, fine. So capacitor will discharge like this. At the same time, inductor will charge like this. Okay, fine. When this is charging, you can observe here, when this is charging, here you are going to get a positive voltage, that is across the diode. So this is the reason why it will be in the reverse bias mode. So diode will not conduct. It will be acting as a open switch. Clear? Okay. Coming to the mode 2, that is switch is off, that is switch is open. When switch is open, IS will not go through. Okay. However, now here, if you remember the properties of inductor, that is it will not allow sudden change in current. However, it will change the polarity. Okay, so earlier it was charging, so plus was here, now it try to discharge. Okay, because it will not allow sudden change in current. IL is flowing like this, so IL will flow like this only. Okay, now it will flow, and here capacitor is going to charge as well as it will supply to the load also. Okay, this is how current will flow. One is this is one path, another one is this path. Okay, that is inductor and then capacitor and then diode. Diode will come in forward bias mode, because now here it is plus and here it comes minus. So when here it is minus, then automatically this will come into the forward bias mode, right? This will be in the forward bias mode. So here potential across VA is greater than VK, so that's why this will be acting as a closed switch. Okay, so one path is through the inductor, then capacitor, then diode. Another path is through inductor and then resistor and then diode. Okay, these two paths, okay, current will flow, IL will flow through IC and IR. Okay, this is how when the switch is off, that is in mode 2, it is going to be working. Okay, so here second thing what we can able to observe is if the capacitor is sufficient to charge, okay, to supply the load, then here it will be in continuous mode. If it is not, whatever maybe the time period is there, if it is not sufficient, then it will come into the discontinuous mode. Okay, it depends upon the circuit. Okay, how we are going to design. Okay, again here whether the current, this I naught current is there, that is uh, if it reaches to 0, then we are going to call it as a discontinuous mode. If it is not going to come to 0 and if it is positive, then we are going to consider it as a uh, continuous mode. Okay, so hope the modes operation of buck boost converter is now we have clarified. Okay, we have got a clarification about this one. Fine. Now let us go to the circuit. Okay, now we will try to discuss the block diagram. Okay, here you will be having a window model, then its MPPT and a buck boost converter and a load. Okay, then measurement blocks. Okay, all these are measurement blocks. Fine. So let us go into the wind model. Here you can take wind turbine model. This is currently I'm working in 2016. So you will be provided these blocks. Okay. However, if you are working in the advanced version, then this will not work out. In such condition, you can click on the library and type here wind turbine. Okay. Then wind in your advanced version, you can do like this. Okay. You take this wind turbine model. Okay. You take this wind turbine model and whatever may be the here uh, from default values will be there. Okay. So these are the actual model values. Okay. You can you can type here the same values. Okay. And press OK, and then you can remove this model, and then you can remove this model and place this model here. That's it. Okay, if you are using advanced version, if it is not going to support, then you can able to replace this one. Okay, fine. Next is here I have used a fixed speed. Okay, if I am going to give a variable speed, then my PA controller I have to design properly. Okay, so currently instead of that one I am taking it as a 14 meters per second only as a fixed speed. Okay, now here you can check, that is nominal mechanical output power I have given is 8.5 kilowatt. Okay, so now I want to convert this into the per unit values. Okay, that is now I'm trying to calculate the torque. Power is equal to torque into speed. So we are going to take this power by speed. Okay, so we are dividing it with the power with the speed, then I am going to get the torque. Okay, this is in radians per second. Okay, so from this one again I am going to take this whatever maybe the speed is there. Again I will try to calculate the I will try to give it as a pitch angle and all. Okay, so this and all is currently not required for you. Better you just remember only the if this block is compatible, then it's okay. Otherwise you can replace the this wind turbine model, and then speed you can fix to 14 meters per second. Okay, that is sufficient for you. After that, whatever may be the torque, here we are actually giving this mechanical power as input. You can observe here, that is our mechanical torque, and we are going to get a output voltage. This is a voltage. It is a variable voltage depending upon the speed. Okay, so that's why I want to convert this into DC so that we can overcome the problem of frequency. Okay, converting AC to DC. Converting AC to DC. In AC, you will be having the frequency, but here the speed is not fixed one. It will be variable one. So that is the reason why we are actually converting the AC to DC so that we can overcome the problem of frequency, and at the same time whatever may be the power generated here, we try to calculate it. Here you can observe that we are uh, we are measuring here the line voltage and the current. Okay, so that's why what will be the formula, root 3 into VL IL cos phi. Okay, I'm considering here again cos phi as 1 only. Okay, then I'm going to get a power here. Okay, here you can observe root 3. Okay, root 3 into VLIR. Okay, so this is the value and I'm converting into the RMS value. Similarly, here this is RMS value. If you remember, so for calculating the power, whatever the VL and IL is there, that is the RMS values. Okay, fine. Now I have calculated here power and I have taken a tag here WP. Okay, signal routing I have given like this. After this one, now I'm using a rectifier and converting this AC to the DC. Okay, this is my DC voltage. Okay, that is after rectifier voltage. Here I am calculating. Okay, here I am measuring. Remember these blocks you have to um, measure. Okay, so WP, that is power, and then the rectifier voltage. Fine. After that, now we can connect. So what is the, how we can able to connect? Instead of doing individually, just select this one, press Control and press again on the block which you want to connect. Okay, then automatically those things will connect. Okay, MPPT, here it is a MPPT technique is there. So I don't want to discuss about these things. Just I will tell you that here we are using a boost converter. Okay, as earlier I told you that most probably we are going to use only boost converters because its sweeping area is more than the buck converter. Okay, fine. So now this voltage again I am giving it to the buck boost converter. Okay, as input. Clear? This is boost converter voltage. Okay, now I want to calculate the voltage. How much is the boost voltage? Okay, here I am measuring the boost voltage. Fine. Now, if you see here, this is our buck boost converter. We will discuss it later at the end. Okay. So this is the our buck boost converter. Okay. So now I am connecting this to a load. Okay. Now I want to calculate the voltage here. Okay. If you remember, okay, you can see here I have connected positive to here and negative here. Okay. And negative here. So that's why I'm using, actually voltage will be here positive, here it is negative. So that's why I'm multiplying it with a -1. Okay, because in buck boost converter, so you are going to get a voltage here plus and here it is minus. Okay, reverse polarity you are going to get. Since I am calculating here I have kept a plus, here I have minus. Otherwise you can do like this also. Here you can keep plus and here minus, and here need not require to give -1. Okay, either you can do like this, or if you want to measure like this, then you have to maintain -1. Clear? Fine. So now I want to give a routing. Okay, so I want to calculate this voltage. Here I am measuring the voltage, and I used -1 so that it became positive, and then I have given a routing signal. Okay, this signal I can use anywhere. Okay, like measuring and all. Now let us go into this one, okay, into the control block. Here I want to maintain a constant 400 volts. Okay, here I want to maintain a output voltage of this buck boost converter as 400 volts. You can see here I have used a load of 50. Okay, fine. Now this is my PA controller. Okay, how to design this one? So your buck boost converter actual voltage and then the reference voltage. Then I have given it to the voltage controller. So these are the my PAD values 0.05 and 0.2. Okay, and then we are going to multiply and divide with the, this is normalization process again. Okay, already we have discussed about this thing. So I am dividing with the 400 so that it whatever maybe the signal is there, it will be at unit. Okay, so then I am comparing this with the sawtooth waveform. Here I am maintaining a 10 kilohertz frequency. Okay, and whatever maybe the pulses are there, that I am giving it to the buck boost converter. That is the buck boost converter switch. Okay, here I have given the switch. That's it. Okay, this is my circuit diagram. Okay, this is my simulation file, and this is a closed loop control, how we are going to design. Fine, and now I am going to run it. So here this block will not be given to you. Okay, so you have to design this one. That is, one is rectifier voltage, that is this one, rectifier voltage, and then another one is boost voltage. Okay, after MPPT, then buck boost voltage, and then power. Okay, all these things you have to calculate, all these things you have to measure. Fine. Fine. This is your measurement block. Okay, this is your rectifier voltage, this is your boost voltage, this is your buck boost voltage, and this is your power. Fine. So you are going to get the power output also. Okay, so here we are going to measure only one, we are going to take only one reading. Okay, however, this thing will not be given to you. This thing you have to remember and you have to draw it. Okay, you have to execute this one. Remember this one. Okay, remember this file. Fine. So this is about the experiment number 6. Hope your doubts has been clarified. And once again, I will just repeat what and all these blocks will be given to you. And here you have to fix all these things. In case your wind turbine is not working, then you can replace with your module. Okay, in your module, you just search the wind turbine model, and that you can able to paste here. And while pasting here, again, you just have to remember that whatever the parameters which we have mentioned here, these parameters same has to be reflected in that wind turbine also. And then here we are going to calculate the wind power. Anyways, all these blocks are already predefined, already you will be given, but this tag may not be there. You have to drag this tag and you have to use there. Okay, fine. Next, rectifier voltage also will be given, and this is the MPPT. Okay, this is the MPPT. This block you need not require to do anything. Simply you just connect this block. After that, you'll be given this buck boost converter block. So this will not be given to you. This you have to design. Okay. So this is your resistor. Hope I have clarified all the doubts here. Okay. This I am maintaining 50 ohms here. Okay. So earlier we have done in a different way also. So here I have used a discrete mode. Here currently I have used a continuous mode. You can use a discrete also, no issue. Okay, So how to do this one? Go to PID controller. How to design the PID controller? Select discrete mode, then your sampling time, then this your PI values P 0.05 and integration 0.2. Okay, here mainly you have to remember this thing. And second is what is the switching frequency we have maintained here. Here we have maintained a switching frequency of 10,000. If you try to change this one, you may not get the result. You may not get, may or may not. Okay, here it is giving okay. This response is also good only. No issue. Currently it is working, but not like the previous one. Okay, not like the previous one. We'll try to change this one as speed also. See here drop you can able to observe. So better you can use this one only. Okay. Currently these parameters have been designed only for this 14 meters per second only. Actually we can able to design this PID controller, but currently I don't want to change all these values because it is a small experimentation, just for your knowledge, and I don't want to make it complicated one. Okay, so this is sufficient. You need not require to confuse anything. Okay, so here you are going to calculate the power and the rectifier voltage, and then here nothing you are going to calculate. You have to give the connections to the buck boost converter, and you have to design this controller. So in this controller mainly you have to remember this thing, that is you have to go to the discrete mode and then sampling time and then proportional integral values. That's it. After this one, this is another one where you are going to maintain 10,000 frequency. Okay, that's it. After this one, you are going to connect it to the resistance. Here mostly you are going to do some mistake. Okay, so voltage you are going to get the negative voltage, since plus you have to connect here, or minus you have to connect here. If you are not going to do like that, then place here -1. Okay, then whatever may be the buck boost converter. Problem is main second thing is here you are going to give one tag, here you are going to take another tag, and that is you should not do like that. Okay, don't copy paste from the whatever may be from your manual. Okay, whatever the name you have given here, same has to be given here also. Okay, please try to remember this thing. Okay, whatever the tag here I have given, same tag has to be given here also. Okay, this you have to remember. After that you have to calculate these four parameters. This block will not be given to you, so you have to design this one. That's it. Okay, fine. So this is about experiment 6. Thank you.